Hi. So today I am going to, let me share my entire screen. Also share, okay. Okay. So today what I'm going to do is solve this problem. This is Leetcode easy range sum of the binary search tree. So we're given a root node of the binary tree, and we are asked to sum all the elements or all the nodes in this tree which fall in this range, low and high. So let's look at this example in the problem, right? So low is 7 and high is 15 here. And both these ranges are inclusive. It means any element that is between or equal to 7 and 15, we should include in the final sum, right? So just looking at the tree, we can say it's 10, 15, and 7, right? So 17 plus 15, that is 32. So that's the final answer. So there are a couple of ways you can solve this problem. And depending on your comfort level of solving this recursively, there is a DFS version of this problem that we can solve it, or we can basically, if you are just stuck, just use the iterative version of this solution, which is basically solving this using BFS. And what it is you basically have a queue and you start level by level, put the root in the queue, and then repeat the process. So if pull the element of the queue, if it falls within the range low and high, add it to the sum, and then add its children nodes onto the queue and repeat the process. And that's a iterative solution in case you are stuck and you are not able to find the recursive solution for this. So we can, I'm in this video, I'm just going to solve this problem using DFS. And what do we need? What basically at every node, what we need to do is find the if the current node is within the range, then include that node in the sum. And since this is a binary search tree which has a property of the root node, the property is the left subtree is less than the root and the right subtree is greater than the root. So we can trim some paths or avoid some paths based on if that particular path falls within the range, right? So for example, when we are at node 15, we don't need to go further right because 15 is our boundary. 15 is your high, right? So anything above 15 is discarded. So we can save some time by trimming some branches, right? Same applies to 5. We don't need to go explore left subtree of 5 because 5 is outside the range of low and high. We still need to explore the right because there could be potentially something here, right? Because it is great, 5 is less than the high, so there could be potentially something here. But on the left subtree, there is nothing because we only go to the left subtree if the root node is greater than the low, right? Does that make any sense? Okay. All right. So let's try to code this. We'll walk through the example after this. Okay. So if base case is if root is equal to null, return my sum as 0. Okay. So now the decision is whether to include the root. So let's do that, right? So if root dot value is greater than equal to low and root dot value is less than equal to high. So if it falls within the range that is given, then include the sum plus equal to root dot value. Okay. Now we use the property of binary search tree, which is whether we want to explore the left or whether we should explore the left or the right subtree. So let's start with the left subtree. So if root's value is greater than low, right? So in this case, 10 is greater than 7. So it is okay. There is potentially, we don't know yet, but there could be potentially nodes that may fall in the range, right? So we want to explore that. So if root dot value is greater than low, then we calculate left sum, right sum. Okay. So let's look at that, and then we copy the function signature. So root dot left, we need to pass left range, and then we need to explore the right subtree. So when do we explore right subtree? So let's take an example of 15. So we are at 15, and we want to go further to the right. But 15 is our boundary, right? So 15 is the high, so we don't need to go. So the case is if the current node's value is less than high, then you can go to the right. And once that returns, once the recursion has returned, right? So then we just return sum plus left, sum plus right sum. Okay, and that should be the answer. So let's run this through, right? Like let's take this use case. So we are at root node. Root is not null. Is root's value 10 greater than 7? Yes. And is it less than 15? Yes. So we add to the sum root's value, which now sum becomes 10 at this stage. Now we go in the recursion. So we basically use DFS, right? So is root dot value greater than 7? Yes. So 10 is greater than 7. We call range Sum BST on the left subtree. So now we are at 5. So does 5 qualify here? No. Is 5 greater than low? No. 5 greater than 7? No. Is 5 less than 15? Yes. So now we go to the right subtree. Okay. So now again we are here at 7. Right. So 7 is greater than equal to 7. Yes. And it's less than 15. So we add 7 to the current sum. Okay. And then we basically return 7 through the recursion stack. So now at node 5 we receive 7, and then it passes it on back to 10. Now at node 10 at the root, we check for the right subtree. We are looking at the decision whether we want to go to the right subtree. So the right subtree is the node's value is 10 less than 15. Yes, so we go 15 here. So when we are at node 15, this 15 falls in the boundaries. So we add 15. And then there is nothing to go on the left of 15, but on the right, we need to check, right? So is 15 less than high, which is 15? No, it is not. So it doesn't go to the right subtree. And then it returns sum of sum plus left sum. And in this case, it is 15 plus 0 plus 0. So it returns 15 back. So now we are at root node, and both the left and right subtrees recursion has returned. And the answer is going to be 10 plus 7 from the left subtree and 15 from the right subtree. And that is, I believe, 32. So we can run this, and we can see it passes. You can submit it. Great. All right. So again, to summarize, if you can't get this solution, just go for a basic DF breadth first search using a queue and solve it. In this case, we use the recursive solution because it kind of makes sense because we can use the property of a binary search tree to decide whether to go pursue a particular path from a node down to its children, right? You can technically do that same thing when you are using a BFS as well. So whichever method you are comfortable with, go for it. And I'll see you in the next video.